Today we will discuss about subnetting, one of the most critical and invaluable skills in the field of networking. As long as IPv4 remains the dominant component of networking, the skills of subnetting will always be in demand. The skills of subnetting is also invaluable for all the network administrators as well as the people who want to clear exams like CCNA or CompTIA Network Plus. The great thing about learning subnetting is it is similar to learning to drive. You only need to learn it once in your lifetime. At the beginning, there will be hiccups, but once you understand the core concepts behind subnetting, things would become easier for you later on. If you follow this lecture till the end, you should be able to handle almost all sort of queries in the field of subnetting. And toward the end of this lecture, we will also learn a shortcut, a trick, which would help you to solve the problem of subnetting in a much easier way, and also it will help you to save time during when you appear for different exams or even when you do subnetting in practical life. So let us first see what is subnetting and why we require subnetting. Subnetting, the definition of subnet is very simple. It is breaking the network into smaller pieces but which are interconnected. So these smaller pieces are known as subnets. Okay. Now why do we require subnetting? One requirement is to reduce the network congestion. As the network grows, say I connect more and more computers in my network, the amount of congestion would increase because a message has to traverse along the whole network. Now if the message can be restricted within a small subnet, a part of the network, obviously the total congestion will come down. The other important aspect about subnetting is it helps in better management of IP address space. Now what does it mean? Now let's use the figure which we have seen in the last lecture. Now look at this third network, this particular network, this bigger network. Look at this network. Now if you look at it, this is a network where many computers are connected. In the previous lecture we have seen that there is a network ID and a host ID. So say this is the ID of this network is 3, and these are the different computers connected to this network. Computer number 1, 2, 3, computer number 4, computer number 5, like this. Now say this organization has many different departments, as normally happens in an organization. So maybe this is an accounts department, this is a human resource department, this is another department. So all these departments have their initial network. Clear? So if I create subnetworks like this, a subnetwork within this bigger network, a subnetwork for one department, a subnetwork for another department, a subnetwork for another department, a subnetwork for the fourth department, and then interconnect the departments, this makes things much easier. It also helps to manage the IP address efficiently because what happens is, once I create and say I buy an IP address, I buy a particular IP address, and then I create a network using that IP address. How we do it, we have already seen in the previous lecture. Now if I want to create another network, one obvious way is to buy another IP address. So say I have created a network for one of my departments. I have bought a class B IP address. Remember, we can connect up to the power 16 computers with that -2 thing. We can create this number of computers in a class B network. Now I have bought a class B IP address, and then I have connected, say, around 500 computers. I have connected around 500 computers in one of my departments, a normal size of a department. Now what happens? A huge number of IP addresses have gone waste because I could have connected this number of computers, but I connected only 500 number of computers. Now I want to create another network for my other department. One way is I buy another IP address. Buying an IP address obviously involves cost. We have already seen some sample amount of fees of buying an IP address. So I buy another say class B address, and then I connect around 700 computers in this other department. Again, another huge number of IP addresses have gone waste. Clear? So a lot of cost was involved in buying a IPv4 address, and then also a lot of IP addresses gone waste. Now, if I could have created this network itself in the previous IP address somehow, then a lot of IP addresses would have been saved. I need not buy another IP address. So this way of logically segregating different networks using the same IP address is known as subnetting. So it helps in better management of IPv4 address space. Now let us see how do we create subnets. Now we create subnet by using some bits for the host part. Now remember the structure of an IP address. The IP address provides you two information, an information about your network and information about your host. That means out of my 32 bits, some bits were used for the network part and some bits were used for the host part, both in classful and classless. In classful, remember in class A, 8 bits are used for networking and 24 bits are used for host. In class B, 16 bits for networking and 16 bits for host, like that. And in classless, in that particular notation, when I say /n, that number of bits are used for the networking part and the other bits are used for the host part. So apparently some bits were used for the network part and some bits were used for the host part. Now because I am creating a subnet in using the same same IP address, now I require to use some bits. I have to use some bits of that particular IP address to create my subnets. Now since out of these 32 bits, some bits are used for networking and some bits are used for the host part, I have to select some bits from those bits itself to create my subnet. So now initially an IP address gave you two information. One is the network and one is the host. Now when I create subnet, I have one more information, which is the information about subnet. Now your IP address gives you three information: the network ID, the subnet ID, and then the host ID. Now where does this subnet ID will be there in the IP address? Now the first thing is when I create subnets, the intermediate routers or the host has to know that we are creating subnets. Clear? Originally, because there is a IP address, and from the IP address we create different hosts. But when we create subnets, how do we let the routers or the host know that we have created subnets? So to let the routers and hosts know that we are using subnets, we use another number which we have already introduced in the last lecture. This particular number is known as the subnet mask. So when we use subnet mask, the intermediate routers and the host know that we are creating subnets in our original network. Now if you do not want to create subnets, if you want to let the network as it is, you simply buy an IP address, connect the host and create one single network, and you do not want to use subnetting. But because you cannot use IP address without using the subnet mask, you have to give a subnet mask. So in case you do not want to create subnets, you do not want to use subnet, you simply use the default subnet masks. Remember, there are certain default subnet masks, and whenever you use the default subnet mask, it means that you are not creating any subnets. But when you create subnets, your subnet mask changes. How does it change? We'll see the process now. Now let us take a class B network. We have taken a sample class B network. It can be any IP address, but we have taken a class B network address. Now remember, by looking at the first octet itself, we can tell whether it's a class A, class B, class C. This we have discussed in the last lecture. Now in a class B network, how many computers I can connect? I can connect up to 65534 computers. Remember, 16 bits are there for the host part, so 2 to the power 16 minus those two. What those two were? The all the zeros and all the ones are not used where we give IP addresses to the host. So we always subtract 2. Now, can you imagine a network with this number of hosts? Normally, we never connect this number of computers in a network. So now basically we want to create subnets. Instead of connecting this number of computers in that network, we want to create subnets where each of the subnets will contain some number of computers. So basically we now want to create subnets. So how do we start creating the subnets? The first thing is we have to steal bits, or we have to take bits from the host part. So in the original IP address there is a network part and we have the host part. So we use bits from the host part to create our subnets. Clear? Now let's see the process. Continue with the process. So this is the ID which I have bought. Okay, so because the class B, the first 2 octets are the network part and the other 16 bits are the host part. Clear? Now the first thing we have to consider is how many subnets do I require. It will depend on my organization. Say if I want to create subnets for each of my departments, then I have to see how many departments I have. If I have 10 departments, I will require 10 subnets. If I have 20 departments, I will require 20 subnets. It will obviously depend on the structure of my organization. So there is the first question. As a person who is handling the network, he has to answer this. Now once you know how many subnets you require, you know how many bits are required to represent that subnet. That means say if I require 10 subnets, so how many bits are required to represent 10? Clear? So say once I know how many bits I require, I steal that number of bits. Whatever number of bits I require, that number of bits starting from the left side of the host bits. So in this example, these are my host bits. Okay, these first 2 parts are the network bits, these 2 parts are the host bits. Now I start stealing the bits from the left side. That means this is the left side of the host bits. So I start stealing from here. I start taking bits from here. Clear? Now let's continue with the example. So say I require 30 subnets. As an example, I require 30 subnets. So how many bits are required to represent 30 numbers? Obviously 5 bits. Okay, so with 4 bits I can represent up to 2 to the power 4, that is 16. With 5 bits I can represent up to 2 to the power 5, that is 32. So because I require 30 subnets, I have to use minimum 5 number of bits. So 5 number of bits are required to create my subnet. So what I do, I have to steal these 5 bits starting from this point. Remember, from the left side of the host bits. So 5 bits I have to take to represent my subnet. So now my IP address will contain 3 information: the network part. So in this example, because a class B, 2 octets will give my network information. 5 bits which I have stolen will give my subnet information, and the remaining bits, how many bits are remaining? 8 plus 3, that is 11. 11 bits will give my host information. So now my IP address, when I have created a subnet, will give me 3 information: the network part, the subnet part, and the host part. Clear? Now using 5 bits, we have to create our subnets. Now the next question that will come is how many computers we can connect in each subnet. So we have created 30 subnets. Now remember, we have taken some bits from the host part. Clear? So how many subnets we can, how many computers we can connect to each of the subnet. If remember, originally there is only one network. In that example, we could have connected to the power 16 minus 2 computers. Now because we have stolen bits from the host part, the number of bits that are there to connect our computers, those numbers have reduced. Originally there were 16 bits. Now because we have taken away certain bits for subnets, now in this example we are left with 11 bits. Clear? So to each subnet now we can connect 2 to the power 11 minus those two. So we can connect 2046 host or computers in each of these 30 subnets. So see the same thing. Originally one IP address where I can connect 2 to the power 16 minus 2 computers. Now with this design I have 30 subnets where I can connect 2046 computers in each of these subnets. Now the first thing, as a person who is creating subnets, who has to answer the questions are that what are the IP addresses of each of the subnet and what are the IP addresses of the computers that are connected to those subnets. Clear? Original question would have been what is the IP address of each of the hosts. So that would have been easy. We have already seen in the previous lecture. Now the question changes. Now the question is what are the IP addresses of each of the subnets, because each of the subnet would have a different IP address. And then what are the IP addresses or what are the range of hosts for each of these subnets. And the other question, and the other important question is how will the routers or the nodes know that 5 bits will be used for subnetting? We have already seen that to enable that the intermediate routers understand that subnetting is being used, we have to use the subnet mask. Okay, by using the subnet mask, we can inform the routers that we are creating subnets. But how do we inform the routers that we are using 5 bits, that we are creating 30 subnets? This question let's first handle. How does the router know that subnetting is being done? This answer is easy, by providing a subnet mask. But how does the router know that we are using 5 bits? The answer is this is done by providing a subnet mask which caters for this 5 bits. That means we have to create a subnet mask which gives this information that 5 bits are used. Now let's come to it again. So this was my IP address and this is the binary representation. Now I would ask you to go back to the previous lecture where we have introduced subnet mask. Clear? We have discussed why we use subnet mask and how subnet mask is used to segregate the network ID and host ID. So if you have not gone through the previous lecture, I strongly advise you to go through it. Now this is my new scheme where I have used 5 more bits to represent my subnet. So I have this network part and this subnet part. Now if I want to segregate my network part, both all the network and subnet part, the network part and the subnet part, if I want to segregate this from my complete IP address, what I have to do? I have to mask this information using a subnet mask. So I have to use all ones for this particular part. For this 16 plus 5 bits, for this 22 bits, I have to logically AND. So all ones. So if I use all ones for this network part, network means both the network and subnet part, so I am left with this number. So 8 bits, 8 bits and 5 bits, all consecutive ones, then rest are zeros. Now this gives in decimal format 255, 255, 248, 0. Clear? So this number, this particular subnet mask will indicate that we are creating subnets. Remember, the default subnet mask was 255, 255, 00. Because it was the class B address, the default subnet mask would have been 255, 255, 00. Now, if that default subnet mask was used, a default subnet mask of 255, 255, 00, that would have been mean that no subnets are being created. Now, because we have used a different subnet mask, that means we are creating subnets, and by using this particular subnet mask, because I'm using 5 ones here, and the rest are zeros. So this number, the decimal equivalent of this number is 248. By using this number, we inform the intermediate routers and the host that we are using 5 bits to create my subnets. Clear? Now this becomes your new subnet mask. Now let's handle the next question. What are the IP addresses of each of the subnet, and what are the range of hosts in each of the subnet? So now let us see the IP addresses of each of the subnet. So let us see the first subnet. What is the IP address of the first subnet? Now we have stolen 5 bits. We have taken 5 bits for our subnet. So this is the IP address originally. So in decimal it would be 135.60.00. Now let me clarify one thing at the beginning. At beginning, when people started to create subnets, at that time this first IP address where the subnet part contains all the zeros, this was not allowed to be the IP address, or this was not allowed to be used. That means the 5 bits are used. For these 5 bits, the starting will be where all these are zeros. Then it will start incrementing, like next will be 1, then 2, 3, 4, like that. So the initial one will be all zeros. Now this all zero subnet was not initially allowed to be used, but these days routers allow you to use this subnet. This is known as the zeroth subnet. So this is the first subnet, okay, where all are zeros. At the beginning, all zeros are not allowed to be used. So in the first example, this is our first example. In this first example, we'll do like that. We'll say use this concept that the zeroth subnet, or where all the subnet bits are zero, that is not allowed to use. Remember, this was the first original use of subnets, but these days this particular address can be used. So from the subsequent examples, we'll be using this subnet also. But for this first example, let us assume that all zeros are not allowed. So in this case, the first subnet would be where one bit is 1. So 5 bits. So this is the first value, assuming that all zero values are not allowed. So 0001, this is my first subnet. So what in decimal format, what it is, 135.60.80. So this is the IP address of my first subnet. Remember, I am using 5 bits for my subnet. So now I have my first subnet. So now I start connecting computers to my first subnet. So what would be the IP address of the first computer connected to my first subnet? Now this would be easy. It would be 135.60.81. So these 8 bits, these 11 bits are there for my host part. So I can connect 2 to the power 11 minus 2 computers. Obviously I cannot use all zeros, so my first computer that I connect to this subnet would be where I use one single bit. So this becomes this value. Okay, so in decimal 135.60.81 is the IP address of my first computer in my first subnet. What would be the next? It would be 135.60.82, then 135.60.83, and so on. This would go on like this, and after that 135 the same thing, 135.60.82, 83, 84, 85, like that. So how many computers I can connect in this subnet? I can connect 2 to the power 11, because 11 bits are left, minus 2. So it will go on like this. So what will be the IP address of the last computer? The IP address of the last computer is where all these are ones except the last bit. Remember, I cannot use where all are ones, because that will be the broadcast address of this subnet. So this would be the last computer of my first subnet. The IP address is 135.60.15.254. Now see the importance of the subnet mask. Using the subnet mask, I can segregate the network part and the host part. Now just by looking at it, you cannot say that they belong to the same subnet. Look at it, .80.15.254. Just by looking at, can you simply say they belong to the same subnet? No, you cannot. So you have to understand the process. So that was my first subnet, and those were my computers. Those were the IP addresses of the host that were connected to that first subnet. Now what is my second subnet? Remember, we have created 30 subnets in this example. So what is the second subnet now? Now it should be easy. So this was the first subnet where it was the value of 1. Now this is the value of the next subnet. So of these 5 bits, now my next value is 0010. This is my second subnet. So what is the decimal equivalent? The decimal equivalent is 135.60.16.0. So 135.60.80 was my first subnet. 135.60.16.0, this is my second subnet. How do we get it? We get it by using these bits of my subnet part. So now what will be the IP addresses of the computers connected to this second subnet? Now this should be easy for you. So the first computer IP address will be 135.60.16.1, then 135.60.16.2, and so on. So this will start from 135.60.16.1 up to 135.60.23.254. From where does it come? Where I have used all ones in my host part except the last bit. Clear? So these are the IP addresses of my second subnet. Clear? So like this, you should be able to find the IP address of all the 32 subnets. So this will go on like this. Once you understand the process, it becomes easier. So all these 32 subnets, I required only 30 subnets, but because I am using 5 bits, I can actually create up to 32 subnets. So I go on finding the IP address of each of these subnets like this, just by incrementing the numbers in this subnet part. So this up to where all bits are 1. So this is my last subnet. So total 32 subnets, and in each of this subnet we can connect up to 2 to the powers 11 minus 2 computers. So now, because we have seen how to find the IP addresses of each of these subnet, I can write out the IP address range for each of this subnet. Okay. Now let us take one more example. Now you are given an IP address 201.130.10.3 and a subnet mask 255.255.255.0. And now you are required to create 8 subnets. In the first examples, we are required to create 30 subnets. Now you are required to create 8 subnets. So you have to find out how to do this. You have to find the IP address of the subnets and the IP address range in each of the subnet. The first thing you notice in this IP address is that this is a class C. This is a class C IP address. Just by looking at the first octet 201, we can say that this is a class C network. You can also see the default subnet mask and understand this. Remember, this is the default subnet mask of a class C IP address. Now in a class C IP address, how many bits are used for the networking part? We use 24 bits for the networking part and 8 bits for the host part. Now remember, we use bits from the host part to create my subnets. Now since this is a class C IP address, the first 3 octets are used to denote my network part. So if I see in my 4th octet there is some number. So by looking at this IP address, I can see that some host information is also included in this IP address, because I know that 3 octets are used for my network part and the 4th octet is for host part. So some host information is also there. So I have to basically use my network address only, not my host part. So I have to first segregate out my network part. Now as humans, just by looking at it, because it's a class C network, I can simply say that 201.130.10, this is my network part. Now but since we are dealing with network, so first let's follow the process to segregate the network part and the host part. How do we segregate? By simply using this default subnet mask. So you are given a subnet mask, so first segregate the network part and the host part. So I have this network ID, this is in my binary format. Then I use the subnet mask, the default subnet mask. I logically AND. We already know the process from my previous lecture. So we logically AND this with the subnet mask, and from this we get our network ID. So this is the network ID of this particular IP address. Now this is the binary representation of the network ID. Now remember, we require 8 subnets. We require 8 subnets. So for 8 subnets, we require 3 bits. So 3 bits, using 3 bits, we can represent up to 8 subnets. So 3 bits is sufficient to create my 8 bits. So from where I will take the bits, I will take the bits from the host part. Remember, in the class C, the last 8 bits are the host part. So we have to take away 3 bits from the left side. So 3 bits we have to take for creating my subnet. Clear? So now, because we have created subnets, we have to use a new subnet mask. So the new subnet mask becomes 255, 255, 255, 224. How it becomes 224? Because we have used 3 bits here, we have to use all ones here. Okay, we have to use all ones here, the rest are zeros. So this is this particular number, and the decimal equivalent of this number is 224. Clear? So now this becomes our new subnet mask, which will indicate that we have created 8 subnets using 3 bits, and now each of this subnet can accommodate up to 30 computers. How 30 computers? 5 bits are left, so 2 to the power 5 minus those 2, so 30 computers can be connected to each of this subnet. So what are those subnets? The subnets would now easy for you. This we have already discussed in the last example. Now in the last example, we have told that we'll from the subsequent example, we'll assume that all zeros can be used. In the first example, we saw that we cannot use all zeros because at the beginning, when subnets were created, at that time all zeros were not allowed, but these days all zeros are allowed. So from this example onwards, we'll take all zeros are allowed. So this is my first subnet where all are zeros. So this is the decimal equivalent. The next one is where I use 1. So this is my next subnet, 201, 130, 10, 32. So I go on like this. 3 bits. So total 8 values, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1 like this. And these are the decimal equivalent. So these are all my subnets. So now the next question is, what are the IP addresses? What are the IP addresses for each subnet? Now, once you have understood the process, the subnet, the IP address of the host becomes very easy. So what will be the first computer of my first subnet? The first computer of my first subnet will be 201, 130, 10, 1. Clear? Now the next one will be 10, 2. So the next one would be 201, 130, 10, 2, 10, 10, 3, 10, 4, like that. Up till what? Up till where all these parts are 1, 1, 1, 1. All ones are not allowed. So this is my last computer. So my last computer, my first subnet is 201, 130, 10, then 0, 0, 0, 1, 1, 1, 1, and 0. Now again, if you follow the process clearly, we need not do it in binary every time. Just by looking at this IP address, we can simply use the decimal equivalent. So what would be the last IP address? Because the next subnet starts from 201, 130, 10, 32. It means the IP address of my previous one. The previous would be my last IP address. Clear? That means my next subnet starts from 201, 130, 10, 32. So the IP address just before it would be my last IP address of my previous subnet. So what would be that IP address? Because the next subnet starts from 201, 130, 10, 32, the IP address just before it would be 201, 130, 10, 31. Clear? Now this is the case where all these values would be 1. 0, 0, 0, 1, 1, 1, 1, 1. Now remember, all the ones are the broadcast address. This cannot be given to any host. So this is the broadcast address. Broadcast address means if I use this address as the destination address, the message will go to all the computers of the subnet. So what is the address just before it? The address just before it would be 201, 130, 10, 30. So this is my last usable IP address of my first subnet. So what are the IP addresses of the computers of my first subnet. They start from 201.130.10.1. It will go on like 201.130.10.2 and so on. And the last is 201.130.10.31. But this is the broadcast address. So the IP address of the last computer would be 201.130.10.30. Now this should be easy for you to understand. Now let us start with the second subnet. So what is the IP address of my second subnet? The IP address of my second subnet is 201.130.10.32. So what would be the IP address of the first computer connected to this particular subnet? It's simply 201.130.10.33. So where this value is 1. So this is 001. Then from this host part, for the network part, this is all zeros. So the first computer would have an IP address where this value is 1, then next one is 10, like this. So the first computer in the first subnet is 201.130.10.33. Next one will be 34, 35, 36, like that, and it will go till 201.130.10. What is the previous IP address of this particular IP address? Because from this IP address the third subnet starts, so the IP address just before this is 63. Now this would be the broadcast address. So this is the broadcast address of my second subnet, and the IP address, the last usable IP address would be 201.130.10.62. Clear? So the range is from 201.130.10.33 to 201.130.10.63. This 63 is the broadcast address. So the last usable one would be 201.130.10.62. Clear? So this way you should continue with all. Let me give you the IP address range for one more. Let's take this one. Okay, for this first, second, third, fourth, fifth, sixth. The sixth subnet. So if someone asks you what is the range of IP address for the sixth subnet, so for the sixth subnet it starts from 201.130.10.161, and the last one is 201.130.10.191, because the next subnet starts from 193. So the IP address previous to it is 200. So this is 201, not 210. 201.130.10.191. 191 is the broadcast address, because this is where all are ones. So this is the broadcast address. So the previous IP address of this is 201.130.10.190. So the range of the IP address of my sixth subnet is from 201.130.10.161 to 201.130.10.191, where the last one is the broadcast address, and the last usable IP address is 201.130.10.190. Clear? In the same manner, you find the range of IP address for all these different subnets. Now let us see different types of questions that you should be able to handle in case of subnetting, in relation to subnetting. Now if you have understood the process which we have discussed, you should be able to answer all of these questions. These are simply a shoot off of the actual process. So if you have understood the process, and I hope that you have understood it, you should be able to answer all these different type of queries. This first query: what is the subnet mask for X number of subnets? So that should be easy for you. If whatever number of subnets I am given, say I have to create 10 number of subnets, or I have to create 12 number of subnets, I have to create 20 number of subnets, I already know how many bits I require for creating those subnets, and based on the bits I can simply find the subnet mask. I have to simply put all ones for that number of bits for that subnet, and using all ones I get my new subnet mask. How many subnets? The number of bits I have stolen to the power to that number of bits. So if I have stolen 4 bits, if I have taken 4 bits from my host part, total number of subnets would be 200 to the power 4 subnets. How many hosts per subnets? This would be the number of bits left from the host port minus 2. So if I have used, say, 4 bits from my subnets in a class C, so that would be 16 minus 4, which is 12. 12 bits would be left, that would be to the power 12 minus 2 hosts per subnet. So this answer of this question depends on the number of bits left for the host part. What are the valid subnets? This is the same thing as finding the IP address of each subnet. This we have discussed using two examples, so you should be able to do it. So basically this question means that find the IP addresses, give the IP addresses of each of the subnet. What are the valid hosts in each subnet? This is again the process which we have discussed, starting from the first computer to the last computer. Valid host means the first computer and the last usable computer, so the range. All these computers are valid hosts. Remember the last one where all our ones cannot be used because that is a broadcast address. Again, we cannot use all zeros also, so it starts from the first computer to the last computer before the broadcast address. So these are the valid hosts. What is the broadcast address? What are the broadcast address for each subnet? The last IP address. The last IP address in each of the subnet is the broadcast address. And in which subnet is a particular host in? This question means you will be given a particular IP address and you have to tell in which subnet this particular IP address lies. That means if I say create 8 subnets, that means this is the first subnet, second subnet, third subnet, fourth subnet, up till 8 subnet. So you should be able to tell in which subnet, whether that particular IP address is in the second subnet or in the third subnet or in the fourth subnet. So this question pertains to that aspect. So you should be able to answer all these questions. Now at the beginning of the lecture I told you that I will be also discussing a shortcut, a trick method which will be used, which will help you save time. Now because we have seen that doing things in binary is time consuming. If we start doing everything using the binary method, it will take a lot of time. So there is a shortcut method available for giving answers to the different type of queries. Now there are also cheat sheets available, some of the sheets which can be created, some tables which can be created, and using this table, by looking at this table, we can simply find out the different subnets and the IP addresses of these subnets. Now remember, such tables will not be available if you take some exams like CCNA, and also you have to actually use the normal method. But there is a shortcut methods which we will discuss. Now remember, do not use the shortcut method without understanding the actual process which we have discussed. First you understand the actual process, then once you understand the actual process, then you can use this shortcut trick. The shortcut trick is very simple. The trick is that to find the subnets, that means what are the subnets? The main question obviously is what are the subnets. Once you find the different subnets, the other questions are simply an association of those subnets. So the main part is to find the different subnets. Remember, we have found the subnets using the normal binary method, putting all zeros in the subnet part, then 1, then 2, and all, then finding the decimal equivalent of those different subnets. Now to find the subnets using this shortcut method, what we do is we simply subtract from 256 the rightmost non-zero subnet value. That means, for example, say this is the subnet mask. Of this subnet mask, the rightmost, that means this is from the right side. For the subnet mask, this is the leftmost side, this is the rightmost side. The rightmost non-zero value. But in this example, what is the rightmost non-zero value? The rightmost value in this example is 0, but we are saying the rightmost non-zero value. The rightmost non-zero value in this example is 248. Under example, if I have this subnet mask 255, 240, 00. Say I have this subnet mask 255, 240, 00. In this example, what is the rightmost non-zero value? The rightmost non-zero value would be 240. So this is the rightmost side. The rightmost side, this is a 0. Again, this is also 0. The rightmost non-zero is this one, 240. So the rightmost non-zero value. So what we do is we subtract this value, this rightmost non-zero value, from 256. Now let us see how this works. Okay, so let us take the same example as the first one. The first example, remember, we have seen the first example 1356000. This example we have taken and we'll be doing the same example using the this shortcut method. So this IP address, and we have to create, remember how many subnets we were required to create? We were required to create 30 subnets. That means 5 bits we have stolen, and by stealing those 5 bits we arrived at this particular subnet mask 255, 248, 0. So the rightmost non-zero value is 248. So according to this trick, we subtract or deduct this number from 256. So 256 minus 248, the value is 8. Now what is the next step is, each of these subnet will increment by a value of 8. Now this is the trick. So first we have subtracted, we have deducted the rightmost non-zero value with 256. What the value we get? The value of we got is 8. So each of this subnet will increment by a value of 8. Okay, so the first subnet is 130.60.80. Remember, because zeroth subnet is allowed, so the first subnet would obviously be 130.60.00. This is my first subnet. This is the IP address 135.60.00. So the first subnet is obviously 130.60.00. And for the subsequent IP address, this will simply increment by a value of 8. Why 8? Because we have found this value 8. Okay, 256 minus 248 is 8. So look at it. How does it increment? 130.68, then 0, then increment by 8. Then another 8, 16. Under 8, 24. Another 8, 32. Under 8, 40. And so on. Up till how much? In this example, we have got 32 subnets. So up till 32 subnets. Now let's match it with my example which we have seen. Let's go back to the first example. Look at it. When we did it in the binary method, look at the IP address 135.60.80, 135.60.16, 135.60.24, 32, 40, like this. This we got in doing the normal binary way. Now using the shortcut method, we have also arrived in the same answer. Clear? So these are my different subnets. Then we have to find the IP addresses. We have to find the IP addresses of these different subnets. This we have already done. This you do yourself. So say for this example, say let's take this example 130.60.24.0. What is the first IP address of the first host? What are the valid hosts? The valid host would be 130.60.24.1. It starts from 130.60.24.1. The next will be 130.60.24.2, and it will go on up till 130.60. The next value starts from 130.60.32.0. So what would be the previous value? The previous value will be 130.60.31. Remember, before 32 the value is 31 and 255, but all ones is the broadcast address. So this is the broadcast address of this subnet, and the IP address just before it is 130.60.31.254. This is my last valid host. So my valid host for this subnet, this particular subnet, is starting from 130.60.24.1 to 130.60.31.254. 130.60.31.255 is the broadcast address. Clear? So this is how we proceed. Now let us take some examples with different type of questions. Now this question is, which subnet is 140.110.32? Then a subnet mask is given 255, 255, 224, 0 in. How many subnets are there and how many hosts are there in each of the subnet? So let's try to first understand the question. Let's try to understand what this question is saying. So I am given a address, a IP address and a subnet mask, and I am asked is in which subnet this IP address is there. That means some subnets have been created, and then I have to tell in which subnet this particular computer lies. So this question is, which subnet is 140.110.32 in, and this is the subnet mask in. That means in which subnet this particular computer is in, or in which subnet, to which subnet this particular computer belongs to. Another part of the question is, in this scheme, how many subnets are there and how many hosts are there in each of the subnet. Now we are already given a subnet mask. Clear? We are already given a subnet mask. Now, first we have to understand how many subnets are there. So in all the examples we have done, we have created the subnets. Now in this example, the subnets are already created. We have to tell what are those subnets, what are the hosts or how many hosts are there in those subnets, and in which subnet this particular host is in. So first what we do is we first convert this subnet mask into binary. So we have converted this into binary, and when we have converted it into binary, we can see that we have taken 3 bits. 3 bits were taken to create the subnets. Here 3 bits were taken, and for in which octet it was taken? It was taken in the third octet. So in the third octet, 3 bits were taken. If subnet was not created, then the default subnet mask would have been 255.255.0.0. Now because this particular subnet mask is used, that means subnetting has been done, and when we have converted into binary, we have seen that 3 bits are used for creating the subnet mask. So how many subnets can be created using 3 bits? Obviously 8 subnets. 8 subnets can be created using 3 bits. So how many bits are left for the host part? 13 bits. So 8 plus 5, 13 bits are left for the host part. So in each of the subnet, we can connect 2 to the power 13 minus 2, that is 8190 per host per subnet. Now let us find out the subnets. So let us use the trick. So what trick is this? We subtract the rightmost non-zero value of the subnet. The rightmost non-zero value is 224 here. So 256 minus 224, the value is 32. So everything will increment by a value of 32. Okay, so the first subnet, assuming that all 0 values are allowed, the first subnet would be, remember we are subnetting in the third octet. So first 2 octets are used for the networking part, and from the third octet, some part is subnet, some part is host. So the first address would be obviously 140.110.0.0. So 140.110.0.0, this is my first subnet. Now from this onwards, it would increment by a value of 32 using our shortcut method. So the next one would be 140.110.32.0. Under 32 is 64, under 30 is 96. While starting initially, you may make the mistake of doubling it. So says you have doubled this 32, then double this to 64, then by mistake you will double this to 64 multiplied by 2, something like 128. Remember, we are not doubling it, we are simply adding it. So it will increment by a value of 32, 0, 32, 64, 96, 128, 160, like this. It will go on like this. So once I know my subnets, I should be able to find my valid host. So what are the valid hosts in my first subnet? My first subnet valid host starts from 140.110.0.1 to 140.110.0. Sorry, the next one starts from 32. So last would be 31.254. 255 would be the broadcast address. 140.110.31.255. This would be the broadcast address. Okay, so this is my first, this is my valid host of my first subnet. Valid host of my second subnet, it starts from 140.110.32.1, and it will go on up to 140.110.63.254. 140.110.31.255. This would be the broadcast address of the second subnet. Okay, now you can go on like this. You can go on for each of the subnet. Now let us go back to the original question. The original question was in which subnet this particular IP address belongs to. Now look at this IP address. The IP address is 140.110.32.1. Now you have to simply see in which subnet this particular IP address will be there, 140.110.32.1. So coming back to this, so which address is given? 140.110.32.1. Now in my first subnet, the range is from 140.110.0.1 to 140.110.31.254. And in the second subnet, it starts from 140, 132.1 to 140, 163, 254. Now, if you look at it, the IP address that was given was this one itself, 140, 110, 32.1. It was asked that in which subnet 140, 110, 32.1 belongs to. Now, if I look at it, this belongs to this second subnet, because in the second subnet, the IP address starts from 140, 110, 32.1 to 140, 110, 63, 254, and this you were asked about this IP address, that this IP address is in which subnet. So you can simply say that this IP address belongs to this particular subnet, this second subnet. Clear? So given any IP address, you can find out the subnet in which that particular IP address belongs to. Now let us take another example. It's the same question, but now this time it is given in the classless notation, the CIDR notation. It is asking which subnet is host 192.168.21.41/28 belongs to. That means you are already given an IP address. You are given this IP address 192.168.21.41/28. You were given this IP address and you are asked that in which subnet. That means some subnets have already been created and you are asked in which subnet this particular IP address is there. So how will you proceed? So first let us convert this /28 into a full subnet mask, to 28 bits. So remember, 28 bits means it is the last octet. Remember, there are 8 bits in the first octet, 8 bits in the second octet, 8 bits in the third octet, and 8 bits in the fourth octet. So here 24 bits, so 28 is, that means another 4 bits from my last octet. So you can understand that this subnetting is being done in the last octet. Clear? So that means all these values, 24-bit values, are all ones. Sorry, 28 bits. 28 bits are all ones. So if I convert it into this notation, in this decimal notation, this is 255, 255, 255, 240. How this is? That means first 8 bits are all ones, second octet all 8 bits are all ones, third octet all 8 bits are all ones, and in the fourth octet, because /28, that means 4 bit from my fourth octet, so 4 bits are 1, and then another 4 bits are 0. So this is in decimal format 240. So /28 converted into full subnet mask is 255, 255, 255, 240. Okay. So by looking at it, how many bits are used for the subnet? 4 bits are used. That means 2 to the power 16 subnets can be created. So 2 to the power 16 subnets have been created. And remember, only 4 bits are left. So in this case, only 4 bits are left for the host part. So in each of the subnet, we can connect 2 to the power 4 minus 2, 14 hosts. That means in this scheme, only 14 computers can be connected to each of the subnet. There are 16 subnets, and in each subnet, 14 computers can be connected. So how do we find the subnets? We can find the subnets by using this simple shortcut tree. 256 minus the rightmost non-zero part is 240 here, which is 16. So we increment by a value of 16. So now these subnets would increment by a value of 16. So this is the first subnet, 192.168.21.0, then an increment of 16, and increment of under 16 is 32, and under increment of 16 is 48, and so on. So these are my valid subnets. Clear? So now let's go back to our first question. What was the original question? The original question was in which subnet this particular IP address belonged to, 192.168.21.41. 2141. Now find the valid IP addresses yourself here in the same process. So for the first subnet is 192.168.21.1 up to 192.168.21. Just before 16, the next subnet starts from 16, so this is 15. 15 is the broadcast address. So the IP address just before it, 192.168.21.14. This is the last valid host of my first subnet. So this you can do for all the subnets. Now, what was the original question? The original question was in which subnet. Let's go back to the original question. The original question was in which subnet 192.168.21.41 belongs to. 21.41. Now if we come back to this valid host, let's come to this valid host 21.41. Now can you tell in which subnet this 21.41 belong to? If I go on finding the host like this, you will come to the subnet in which that particular IP address will be there. But just by looking at it, you can see it. 21.41, to which subnet will belong? If I look at this third subnet, it will belong to this third subnet, because in this third subnet the IP address should start from 192.168.21.33. so the first computer is 33 in this subnet. From 21.33 it will go up to 192.168.21, just before it 47 will be the broadcast address, that will be 44. So from 33 to 47 these computers will be connected in this third subnet, because we are asked about 41. So this 41 will obviously be in this subnet, because in this subnet the computers are from 33 up to 47. So this dot 41 will obviously belong to this particular subnet. So that IP address, the question was to which subnet that IP address belongs to. The answer is that IP address belongs to this particular subnet. The subnet is 192.168.21.32. Clear? Same example. Similar example, in which subnet the host 10 210 240 20470/12 belongs to. Now this is a similar question, so I'll not explain it in detail, so you have to follow the same process. Why I'm showing more examples of this type is because this type of examples carries in itself all type of questions that can be answered. That means what are the subnets, how many subnets, what are the IP addresses of the subnets, what is the broadcast address of the subnets. All type of questions are included in this particular type of question. So in which subnet this host belongs to find out, you have to find out the subnet mask, then you have to find out how many subnets are there, you have to find out the subnets, you have to find out the IP address of the subnets, you have to find the broadcast address of the subnet. So all the questions are answered in this one particular type of question. And another reason for giving this many types of examples of the similar type is that you should not make a mistake of creating the subnets in a incorrect octet. That means, remember in the first example the subnetting was done in the third octet. In the previous example the subnetting was done in the fourth octet. So you should be very clear in which octet you are doing the subnetting. Do not make a mistake of doing the subnetting in one particular octet. Because we have seen only one example, say you have seen an example of some say class C subnet where the subnetting was done in the last octet, and then you start doing subnetting in the last octet for every example, for every problem. It is not like that. So you have to see in which octet the subnetting is being done. Clear? Do not make that mistake also. Some people make that mistake. So in this example 12 bits are used, okay, /12 bits. That means 8 bits are already there in the first octet. So this is the first octet is 255. 12 is 8 plus 4. That means 4 bit. 4 bit is taken from the second octet. That means now the subnetting in this example would be done in the second octet. Now converting it into subnet mask, where this in the second octet 4 bits are 1 and 4 bits are 0. This is 240. So 255, 240, 0, 0. So 4 bits are used for subnetting, because when I convert it into binary, 4 bits here. So 4 bits are used for subnetting. So because 4 bits are used, we can create 16 subnet. And because 4 bits are used, so how many bits are left for my host part? 20 bits are left. Clear? 12 bits in this network part. Out of these 12 bits, 4 bits are for the subnet, and remaining 32 minus 12, that is 20 bits are left for my host part. So how many computers I can connect? I can connect 2 to the power 20 minus 2 hosts. Remember, this minus 2 would be always there. So if you are asked a question where how many hosts can be connected, the number of hosts that can be connected, always 2 to the power the number of bits available for the host minus 2. All zeros not allowed, all ones is the broadcast address. So this number of hosts can be connected. So to find the valid subnets, I again follow the shortcut. 256 minus the rightmost non-zero part. The rightmost non-zero part is 240. This is 16. Now every value increment by 16. So 10, 16, 10, 32. Now remember, we are doing in the second octet here. This is the second octet. So this increment is being done in the second octet. Okay, so this is one area where people can make mistake. So 10, 16, 10, 32, then we can go on like this. So we're jumping 6 times, that means 64, then all this, every time it is increment by 16, then we go to 192, 208, 224, 240 like this. It's incrementing by value of 16. Going back to the question, 10, 210, 204, 70, 204, 70. Now just by looking at it, you can tell that in which subnet this particular IP address will belong to. Just by looking at it, you can understand that this would belong to this subnet, because what would be the valid IP addresses in this particular subnet? This would start from 10.192.0.1 to 10.207, 255, 254. By now you should be able to tell this. So it would start from 10.192.0.1 to 10.207. The IP address just before it 207.255.254. Here 254. All ones are not allowed. So this IP address 210, 200, 470, 200, 470 would be in this range itself. Okay, from 192 to 207, it would be in this range. So that particular IP address belongs to this particular subnet. Clear? So we have come to the end of this process of subnetting. If you have understood the process, you should be able to do any sort of problems that can come in this process of subnetting. So I have given you some homework. Okay, so attempt these homeworks. You should be able to do all this homework. These are simple questions, but follow. You can also use the shortcut method, but ensure that you have understood the process if you use the shortcut method. So these different type of questions are just a spin-off of what we have done. So you should be able to do all these problems on your own. So these are some 5 homeworks. Then another, I guess if I have some more homework, yes, some more homeworks are there. So different types of homeworks in different notations. Some are classful notation, some are classless notation, somewhere the subnet mask will be given, somewhere the IP address will be given, somewhere you will be asked to find what are the different subnets, somewhere you will be asked to create a subnet scheme. Okay, so perform all these homeworks and complete these homeworks on your own. So this completes our subnet part. In the next lectures, we'll be discussing about the IP headers. So IP headers we'll discuss in the next lecture. Then we'll discuss about fragmentation. In IPv4 headers, there is a specific thing known as fragmentation, which we'll discuss. Then we'll discuss the IPv6 header as well. Thank you.